Hi, everyone. Welcome to Best Practices for Building an In-Game Economy with LiveOps. So my name is Rambod. I'm the Director of Engineering for the LiveOps team over at Unity. I've been here for about 8 years now, and before that, I was a game dev for 12 years running my own studio. I have lived through the highs and the lows, taken down our entire backend over Christmas because we just were not ready for the scale. And it's all of those things that get us excited to come here today, to help you all have to only worry about making the game and not having to worry about building out the backends and those things that actually don't really lend anything to your game design.
And hey, I'm Dyer. I'm one of the engineering managers here within the LiveOps organization. Like Rambod, I've been at Unity a very long time, just over a decade now. And before that, I was shipping everything from console PC games to small indie mobile games, running my own backends and failing occasionally, as we all have from time to time. So let's jump into this thing. We got a lot to cover today. So we're going to start with an overview of LiveOps and game economies. We're going to give a quick intro to what Unity Gaming Services is. We're going to talk about an out-of-the-box economy solution, and then we're going to talk about how you might build a custom economy solution for your specific game. So let's start here. What is LiveOps, right? I think we probably all heard this term. We all know that, like, if you look at the data, right, all of the most successful games are LiveOps games being operated as a live service. So the way we tend to think about this is kind of in this flywheel. So we have build, manage, and learn. We want to build games that can be modified over the air, where you can ship a binary and your content separately. We want to be able to manage that content and organize that into releases that can be tested internally and then released on a schedule. And then you probably have some hypotheses about, some changes you might like to make in your game. And we want to actually use data to inform our decisions, so we're not just guessing, right? We don't want to just make a change and hope for the best. We want to try something, see if it works, look at the data and see, was this successful or not? So the place we like to start is, we really think economies are kind of the foundation of player engagement in a lot of these super successful mobile games. Right? We want to build a game that stands the test of time. We're not just releasing something and hoping for the best, and then, over time, your players are disengaged because there's nothing to do. Right? They run out of things, and there's nowhere to go. So it's really, really critical that from the beginning you think about kind of the design and technical execution of how you're going to add this kind of progression and economy system. We really think that successful economies are something that supports your core game loop, right? It's not something you just tack on at the end and hope for the best. It's really something that is really well thought through and is really, really the core part of your player engagement. One of the tricky pieces is getting the balance right, though. So you really need to think about, in these terms, we think about it as sources and sinks. So where are the sources of currency in my game? Where can I earn currency, and where can I spend that currency? Right? It's not very fun if you just earn tons of currency and you have nothing to spend it on. You're like, all right, this is boring. And conversely, if you have tons of stuff to buy but you have no currency, it's also boring because you're like, this is frustrating. I can't buy anything. So getting that balance right is very critical to engagement. I'm sure you all know this, but we're just trying to cover all our bases here. So cool. And then we like to talk about some of the technical challenges of actually making this a real thing. You really want to make sure people can't cheat, right? You want to look at server authority for those things. You probably don't want somebody to just take their jailbroken iPhone or their random side-loaded Android device and grant themselves all the currency and screw up your multiplayer economy. And then, again, kind of coming back to this flywheel, we want to use data to inform our decisions, right? We want to actually understand, like, when we make some change, what impact did that actually have? And one thing we know is players want frequent content updates, so really thinking about this from the beginning of, how do I deliver content separate from my game builds? So if we could kind of sum up one thing, I really think this is kind of the key point, is you should be building with LiveOps in mind from day one. We have to actually think about it from the beginning and really make it a central part of your strategy.
UGS is fundamentally a platform of backend and LiveOps services that are used by world-class teams to support live and multiplayer games at any scale on any tech stack. And this means everything from no matter what engine you're using, if you already have some back-end parts that you want to complement with parts of UGS, you're more than welcome to do so. You can use the whole thing end-to-end or pick and choose different parts a la carte. So some of the biggest games today are using our services, from massive teams with Second Dinner and Marvel Snap that come from professional studios that wanted to be able to move very quickly as they wanted to start their own company and iterate as quickly as possible, to smaller teams like Shallot Games with their game Coffee Golf that just happened to have a smash hit on their hands, all built with a team of 2 people that are now running successful live ops and generating successful revenue. And Kinetic Games for the game Phasmophobia. That was a game that was in development for over 9 years before it started seeing a lot of success over the last 3 years. And we're helping them transition that game into a live service model so they can continue to drive business success, but also delight their players over a long period of time. So we have a lot of services as part of a UGS. But when you think about them, they can be broken apart into 3 sections. We have our multiplayer services up here, like Relay, Matchmaker, Lobby, and Game Server Hosting, and now Distributed Authority. This is all about getting your backend set up for multiplayer games and getting the players in so they can play together. We have our communications and safety products, and this is all about how players can interact with each other, from friends and leaderboards to create social communities and Vivox voice and text chat, but also safe voice and safe text to deal with toxicity and moderation. Because as we know, when players can interact, bad things can happen as well, and we want to make sure that you're able to have safe communities where players can interact with each other. And lastly, where we're going to focus today is going to be on the LiveOps side, where we have everything from authentication and player management, so you know who your players are, and then you can manage them as well. And analytics, push notifications, and game overrides, where you can learn about who these players are, and then personalize the experience for those players. We have Cloud Code and Cloud Save that essentially make up our game backend products, where you can have essentially a database in the cloud and then be able to create a server authoritative API wrapper around UGS that's specific to your game. We have remote config and cloud content delivery, where you can send either assets or configurations over the air to, again, avoid downloading a binary, because every time players go to the App Store, it's a great time for them to find their next favorite game. And lastly, we have cloud diagnostics for crash reporting, and soon we're adding A&Rs, as well as IAP for being able to run your in-game economy without having to implement the individual store SDKs. And these services are being used right now on these games. So one thing we're going to say is that please come work with us. These services are battle tested, but the feedback that we get from these studios that we work with has only helped us make these services better. And we're not done, and we're continuing to improve them.
Yeah, we're always open to feedback. Come find us after the talk if you want to talk to either of us directly about any of these services. We'll be out on the floor as well tomorrow, and we'll have Q&A at the end. So lots of options. All right, cool. Let's talk about how you might build this out of the box game economy, right? So one of the solutions we offer inside of UGS is actually just called Economy. And it's a very accessible solution here where you can basically define a few things, from just setting up your basic currency, your items. You can set up your in-game transactions and actually link that to your real money transactions, your products that are set up in the app stores. So it's very easy to just get something configured and going right out of the box without needing to do a bunch of extra work. I'm going to show you some workflows here that in the dashboard, but all of this can also be configured from the editor and deployed as config as code using the CLI or directly from the editor itself. So you kind of have a lot of options, but I think this is kind of cool to see what's available in the dashboard as well. So if we're going to start, the place we would normally start is let's define some currencies. You might have some gold coins, you might have some premium gems or something else, but all you really need to do is give it a resource name. So here we gave it gold coin. It automatically assigns a resource ID. You can change that if you want. And then you just give it some basic values, initial starting balance of 100 and a maximum value here of 10,000. You can also just make it unlimited. And then the cool thing too is you can actually attach arbitrary JSON if you need some metadata, right? If you want to add, for instance, a path to some UI elements, or I don't know, whatever you need to add there. There's kind of a lot of options. Then you might go in here and define your inventory items. So here we're just defining a health potion. Same thing. You just give it a resource name. It assigns a resource ID, but you can change those if you have some other naming scheme you like. And this is the basic of nothing else needed, but again, you can add this arbitrary metadata. So if you need, maybe it's the actual amount the health portion restores, like the health in the game. Maybe it's the the mesh that's used. Maybe it's the UI elements. It could be anything. And then the cool thing, too, is when you actually use these at runtime through the SDK, you can also attach instance data. So instances of these items can then also have arbitrary metadata associated with them. And then the last step before you actually set up anything in the app stores would just be defining your virtual purchases. So these virtual purchases are, it costs this much currency to buy this specific item. So here we're saying it costs 10 gold coins to buy 1 health potion. And the same thing, there's some metadata there. I don't know that it'd be particularly useful, but it could be. Maybe you have some of the UI elements as well for those purchases or something else. And then lastly, setting up your IAP, so your real money purchases. And this is as simple as linking this. You basically can put in the App Store and Google Play product IDs, and then tell it what the player received. So here, this is a purchase for 100 gold coins. Maybe you could buy the items directly. You can assign really any of the resources here. And then the cool thing is we have all of this is available through the player management in the dashboard. So you can search for individual players. You can see everything from their login time to when they were created, and then you can actually see all of this stuff in economy. So you can see how much currency they have, you can see what inventory they've been assigned, and you can even see the instance data that if you have the items, if they have some sort of instance data and metadata attached, you can actually see all of that directly through the dashboard. And then when we talked about personalizing experiences, we also have this game overrides product, which I think is really cool. So this allows you to both target specific players with some changes. So here we have an example of we're targeting new players. This is kind of walks you through a wizard, a nice step-by-step process. You can choose a lot of different things in the targeting depending on your use case, right? We have a bunch of predefined audiences, but you can also target things very granular down to specific device types, to geographic regions. There's a whole lot of things in there. And then you would provide some specific overrides. And this could be, this is kind of where we're coming back to learning from our changes. This is where you would be potentially either providing, as an experiment, maybe 2 different variants, or you would just try this variant over a period of time and you would see how it performs. Here, this is like, maybe we just need to give all our new players 25 gold instead of whatever, 100, and see how that impacts our engagement, right? And then the cool thing is there's a whole scheduling feature around this. So if you want this to start now and just run for 2 weeks, you can do that. If you want it to start at the new year and run for a month, you can do that. It's cool. You can just have all of that set on a schedule, and you don't have to be there to press the button when it needs to go out. It can just run and stop automatically, and you can view all of the results from running that experiment. So this is all cool. It's a nice out-of-the-box solution, but sometimes you're going to need something more custom, right? You're going to want to build something very specific for your game. So what do we do in that case?
Well, we need to build a custom game economy. So what we're going to build today is, let's say we have a game with health potions, and we have a couple of requirements that we want to be able to hit. One is potions need to be stackable. So if a player has 10 of them or up to 99, we can put them all in one stack. The other one is we're going to have a game UI in our game where it's just using consumables. So we want to be able to populate that quickly while using server authority and not relying on the client to be able to handle that. So this is a quick overview of our solution. We're going to use authentication to give us access to player management, but then so we also have a player ID. This is going to make storing player state and cloud save very easily because now we know who a player is. We're going to use analytics to give us some off-the-shelf insights and then custom events later as well to get that custom game data that we're going to need in order to make better data-driven decisions. We're going to use remote config for our configurations, and this is where we're going to store the definitions of our currencies, our items, and our virtual purchases. We're going to use Cloud Code to, again, create a custom game API around our system to also bring server authority to the system as well. We're going to use Cloud Save, which is going to store the state of the player. So this is both the inventories, the currencies, and everything else about our players. We're going to use triggers to actually set up the player for the first time after when they create their account and instantiate their starting inventory. And lastly, we're going to use game overrides to be able to then run A/B test or personalize the experience for our players.
And this looks a little scary, but I'm going to break it down step by step, so it'll be nice and easy.
So first, let's go ahead and get our initial thing set up. The first thing we're going to do is use the package manager to install the following packages. The first one is authentication, remote config, cloud code and cloud save, then Wire, which is our sockets gateway for cloud code to allow us to push messages down to connected game clients, and then analytics and our IAP SDK as well. And then we're also going to set up the CLI because not necessarily want to do everything through the dashboard, so we're going to go through a lot of the config as code templates for the things that we'll be doing. First, you need to install the CLI. After that, you set your project ID. And then you want to set your environment ID. And this is super helpful for compartmentalizing changes. So that way, if Danny and I are on the same game team, we can both make changes to our backends without having to clobber the changes from each other. We can check our config as code into source control, merge it there, and then push it to our staging and then our production environments. And then we're going to go ahead and log in with our Unity ID. So now that we've got all that set up, we're going to go ahead and log the player in. The first thing that we need to do is initialize the Unity services, and this takes care of the dependencies between all the different packages and gets them all started up in the right way. Then with one line of code right here, we can actually just sign in our players anonymously, because we see this pattern emerge a lot where if players get hit with a login screen the second they open up the game, it might lead to not great retention, and they'll probably drop off. So what we see a lot of games do is log players in anonymously, so you have that player state, you have that player ID, have them play a little bit, and when then you think they're hooked, you can hit them with a login screen and say, hey, if you want to carry your progress across devices, please log in, and you get to do that. At which point then you can link their ID with the login provider of their choice, whether it's Apple, Google, consoles, or Steam. Then we're going to set up our analytics. And the big thing here is that the analytics package will not start collecting data by default unless you get player consent. Now, we're both not lawyers, so we're not going to get into the legal ramifications of different territories. But once you do get the consent, when you call this Start Data Collection API, and at that point, we have been collecting data on the cache locally, and once we have consent, we'll start sending that data to the backend. So you're also not losing any session data if you wanted to show the consent later on in the session as well.
Yeah, I think it's really cool. Just with this one line of code, you're already going to get a bunch of things out of the box, like DAU, MAU. You're going to see retention, a bunch of things, like without having to instrument any more events. Obviously, you should instrument all your events along the way, but just this, like one line of code, you've got a ton of really useful data. So from that, I'm going to walk you all through how to set up the currency. Right? So we're going to start with remote config, which is our configuration data store. So this allows you to hold configuration on both the server and the client. Right? We're going to start here with something simple, just economy currencies, and we're going to define two different currencies, gold and premium gems. It's pretty straightforward. We give them some names. We give them some balances, some maximum balances. And then you might define some icons in this way, right, where you're saying, hey, here's the path to this icon that we're going to use at runtime. The reason this is really useful is because you can use something like addressables and cloud content delivery to then update that on demand. Right? Addressables is a nice system to be able to reference assets by name or by path at runtime. And cloud content delivery is an easy way to then deliver any of that content remotely. So it's cool because you can kind of organize it into buckets based on platform. You can basically create releases, which is essentially you can think of it like a Git commit, right? It's like all of the stuff in this bucket at a specific state and time. And then you can promote that across these environments. So if you have a staging environment, a production environment, you can roll those changes out across environments. We're not going to go into the technical details of this, but just wanted to quickly mention it. Cool. So then, now that we actually have our currency configuration defined, we need to figure out, okay, well, how do we store this for an individual player? Right? So we're going to store this in CloudSafe. And you can see here that I said it's stored as player data. Well, there's two types of data that we can store in CloudSafe. One is player data, and one is game data. And player data is exactly what it sounds like, right? It's data that's associated with a specific player, and it's only accessible to that player. Game data is kind of what it sounds like usually. Game data is data associated with something larger scoped than just an individual player. So it might be level data that changes. It might be asynchronous multiplayer turn data. It could be, I don't know, it could be the back end of how you're building a clans or guild system, any of those kinds of things, right? It's just kind of like stuff that's not associated with an individual player. But obviously, if we're storing a single player's currency, we're just going to store that as player data. So the simplest way is we're gonna have a key for each currency that we have. Here we have economy, currency, gold, and we're just going to store the value directly as an integer. There's a lot of options here. Cloud Save is just a key value data store. You can save any types in here. You want to put some strings in there. You want to put some JSON in there. It's totally fine. You could certainly save the currency as a big JSON block and save all the currencies in there. I just find that this is easier to work with. You can directly reference that individual key you're looking for, and it makes it easier to increment and decrement and not have to parse all the JSON every time. Cool. And then when we talked about a server authority, right, we offer these things called access control rules. So this is an easy way then to define what things can be run on the client and what things can be run on the server. So the cool thing is you can actually define multiple rules, and they'll apply in least specific to most specific order. So here you can see we're starting with a rule that just says we're going to deny all actions to the client. So we start with that, and we just say the client can do nothing, right? This principal player here. And then we're gonna allow just read access of some of our cloud save data. Now, you could set up any kind of rules you wanted here, and make different pieces of data readable or writable. You may not want full server authority on everything. You may not care about some of the data. It's just fine. You have a single player game. You may be fine to just completely write everything from the client. But this is how you would get at least very basic server authority for your player data. And then we're going to create a Cloud Code C# method for the first time a player is initialized. Here, we're just going to use a constant of, I'm going to give 100 starting currency. You probably, in the real world, want to pull this from a remote config. I'm just trying to keep these slides as condensed as possible. You can see here, all we're really doing is kind of this set item async. This is like the main purpose here. Is all we're doing is we're taking this key of economy, currency, gold, and we're setting it to this starting currency of 100. And then we send a message to the client. So we just tell the client, hey, I have a message. Here's the value, and the client receives the message if it subscribes to callback. So it's as simple as on the client side, all you have to do is subscribe to these player messages. There's a bunch of different callbacks that you can get. One of those is message received. And here we're just checking the event type or the message type that we just set. And if its currency was updated, you might display some changes in the UI. You might take some other kind of action on the client side. But really, it's just I want to load this new value from Cloud Save, and we can do something with it now. And then the last piece, that's cool. We created this C# method, but how do we actually run this method? Well, we have this system called triggers. And the cool thing about triggers is it can just run in response to a bunch of events. So one of those events here is this, you can see player auth signed up. And so as part of this event, in response, we're going to run this method that we just created. There's other triggers for things like leaderboards being reset. There's things for, even if some of the data in Cloud Save changes, you can actually run code in response to that. So there's lots of different options here, and it's really cool to be able to put all of those things together.
Cool. And now that we've got our setup complete, we've got currencies, we're going to go ahead and create our virtual purchases. So again, here we're going to use remote config to go ahead and create the economy items. We're going to have that as a top-level key to just make it easier to fetch just that one item if we want to. Then, like before, we're going to have our health potion, the ID of the actual item itself be the top level. And then inside that, we're going to have the human readable name, path to an icon, let's say a mesh, and the item type, which is going to be critical here because we're going to use this later on for queryability purposes as well as a max quantity. One thing that you could also envision adding in here for health potions is, well, what it does in the game. Maybe a set of instructions of, health plus 5, health plus 25. So if you want to change that as well over time, you can do that through remote config. Here we've also just created a basic sword as well, just to show you can also have a weapon type as opposed to a consumable. So once we've done that, we're now going to go ahead and create our virtual purchases in remote config as well. So here we have our top-level keys in case you want to get your store or your virtual purchase store. You can just fetch that one key. Then here, we're going to have the health potion, but _1 and then _10 here. And this is for either buying a single potion or buying 10 potions in a bundle. And inside of here, we're going to have the currency type. So this is the type of the currency that the purchase is going to take. So in our case, gold. The cost in that currency. So for this one potion, it's going to cost us 10 gold. For 10 potions, it's going to be 75 gold to make the bundle worthwhile. Then we're going to have the item type that is going to be granted by the purchase. So again, this is going to be tied to the ID that we just created on the last slide. And then the quantity of the items that you're going to get. Now, for this part, we're actually going to use Cloud Save game data. And this is because of the one requirement that we had in our game where if we show the consumable menu, we only want to fetch and show those consumable items. And the challenge is if we use player data, at some point, our game's running for 10 years, you can imagine that inventory is going to get very, very long. And Cloud Save does have limits per key. So now our inventory could be chunked across multiple keys for an individual player. And rather than having to fetch each one to figure out which one contains the consumables, this enables us to just run a query over all the data to get one specific player's consumables. So we're going to save this with a random GUID as the ID instead of the player ID, but we're going to store the player ID inside of the key here. We're also going to have the item ID, so in this case, health potion, and the item type. And this is, again, what's going to let us query for just the consumables for an individual player. And the quantity of the item here as well. So in our case, the player has 10.
The other cool thing about storing this as game data rather than player data is, maybe we want to implement a trading system in the future, right? Now we can very easily query across all of our players when we're looking for a specific item ID. So it gives us a lot more flexibility.
And then this is the configuration or the config as code for being able to create the indices within Cloud Save. So we're going to have our index config, and we're going to define the fields that we want to actually index within Cloud Save. So here we're going to index the player ID and the item type, and we're going to do it all in ascending order. Not that it really matters for our use case. And then this is going to be the Cloud Code C# module that we create for actually doing the purchases for the items. So we're going to execution context, which is going to give us things like the player ID, the environment, and a service token if it was passed in. Our API client allows us to communicate with the other UGS services by using their SDKs as opposed to having to write manual web requests. We're going to take the push client that enables us to push a message down to the client like we did before. And we're going to take two parameters here, the player ID just for easier access, as well as the purchase ID that we created in remote config. So too much code to put on the slide here, but we're going to walk you all through it. So first, we're going to load the virtual purchase definitions from remote config, and that's that economy virtual purchases key that we had created. We're going to then load the player's currency from Cloud Save player data by just using the player ID. Then what we're going to do is first go check, OK, the player wants to buy the 10 health potion pack. Do they actually have 75 gold or not? If they don't, we're going to return to the client with an error message with some sort of text that we want to display on our UI, notifying the player that they don't have enough currency, they need to go buy more and keep playing the game to earn it. And then if they do, we're going to remove the currency from the player's balance in memory. We're going to then query for the matching item type from non-Cloud Save game data that we had just set up. And if it returns back as null, well, we know the player doesn't have any health potions yet, so we can just go ahead and create that data. And if it does return with something, well, we add the 10 health potions back, and then we rewrite both sets of data at once back to Cloud Save. And then if we want to on the game client now, whenever we want to pop up our consumables menu, we can just run the query directly from the game client. So we're going to go ahead and construct our query using the Cloud Save APIs. We're going to put the fields that we want to filter on. So in our case, it's going to be the player ID and the item type. We're going to pass in the player ID from authentication for player ID. And for the field, we're going to, the item type, we're going to put in consumable because, again, we want to show all of the consumable items. Then lastly, we're going to create a hash set that is going to be all the parameters that we want returned from that item definition. So if we have other things in there but we don't necessarily need them returned, we can omit them if we want to there as well. And then we're just going to await the query running against our Cloud Save database. And now because we've set up remote config, we can also just run game overrides over those. So let's say we want to run a test where if we make the 10 health potion gold value a little bit less, does that encourage more purchases? We can now run that A/B test. Or maybe this weekend we want to give a sale to our spenders and say, hey, it's 50 gold instead of 75 gold. Because we're using remote config, we can test on any of those keys in there. Or maybe there's a change we want to make that's a little bit too risky. We can incrementally roll that out to like 1% of our new players, see how that goes, and then roll it out to more players over time. So we just covered quite a bit, but what we did was we defined our currencies and our items in remote config. We've stored the player inventory and the currency balances in Cloud Save, where the currencies are in Cloud Save player data and the items are in Cloud Save game data. We've created our server authoritative code and the workflows in Cloud Code. And lastly, we can now target specific audiences from analytics within our game override system.
And if you think about this kind of thing we just walked through, right? This framework is really applicable to a lot of different use cases. You know, you could build a quest or achievement system very similarly, right? It's kind of the same thing. You have some configuration you need to define up front. You have some server authoritative workflows you need to run, and you need to save some data for the player every time somebody finishes a quest or gets an achievement. These are just a couple of the random examples we kind of thought of, but there's really no limit to kind of what you can build with this stuff. So really cool.
Yeah, one really cool one is like the limited time events or items. Because you can override the configuration, you could just set up a override that is the entire configuration plus some extra items that might run during a season in your game or maybe for a weekend event. And then once that's over, that item is no longer there as far as the definition goes for players to be able to attain it.
So cool. We covered a bunch of stuff. I think, again, coming back to the beginning, I want to harp on this point, build with LiveOps from day one, right? Really think about this stuff from the beginning of how is this going to be fit in with the rest of my core game loop, and thinking about how does player engagement work and the progression, and really both from a design and a technical standpoint. We also covered an out-of-the-box economy solution that we offer, which is very easy to get set up. And then we talked through how do you build a very custom tailored solution using our services for your specific needs, and potentially any other use cases you have very similar. So what's next? The biggest thing, if y'all went to the keynote this morning, you will have seen Rambod talk about a bunch of this, right? We're working on rolling out release management across all of our services. So it's going to make it much easier to then QA test and privately stage content before it goes out. And also being able to just monitor using cloud diagnostics, seeing from release to release, how does this affect my game health in terms of crashes and the logs that I'm seeing and ANRs and all of that stuff. So really cool. There will be a QR code at the end of this you can scan if you're interested in requesting beta access. So that'll be up in just a second. And with that, we'll take some questions, and I'll leave this up on the QR code if y'all want to scan it.